second midterm exam. Question number 1. Corporation randomly selected or selects 150 sales people and finds that 66% who have never taken self-improvement course would like such a course. So in this case, currently they select 150 sales people and find that 66% would like or who have never taken this course. The firm did a similar study 10 years ago in which 60% of a random sample of 160 salespeople wanted a self-improvement course. So in the past, they select a random sample of 160 and found that 60% would like to take this course. So we have here two information about previous study and currently. So currently we have this information. The sample size was 150 with the proportion 66% for the people who would like to attend or take this course. Let pi 1 and pi 2 represent the true proportion, it means the population proportion, of workers who would like to attend a self-improvement course in the recent study and the past study respectively. So recent pi 1 and pi 2 is the previous study. Test whether this proportion has changed from the previous study by using two approaches, a critical value approach and p-value approach. So here we are talking about pi 1 equals pi 2. Since the problem says that the proportion has changed, you don't know the exact direction, either greater than or smaller than. So this one should be pi 1 does not equal pi 2. So step 1, you have to state the appropriate null and alternative hypothesis. Second step, compute the value of the test statistic. In this case, your z statistic should be p1 minus p2 minus pi 1 minus pi 2 under the square root of p dash 1 minus p dash times 1 over n1 plus 1 over n2. Now p1 and p2 are given. Under the null hypothesis, pi 1 minus pi 2 is 0. So here we have to compute b dash, which is the overall proportion. And b dash equals x1 plus x2 divided by n1 plus n2. Now these x's, the number of successes are not given directly in this problem, but we can figure out the values of x1 and x2 by using this information, which is n1 equal 150 and p1 equals 66%, because we know that p1 equals x1 over n1. So by using this equation, x1 equals n1 times b1. n1 150 times 66%, that will give 150 times 66, so that's 99. So 150 times, it's 99. Similarly, x2 equals n2 times b2. N2 is given by 160, so 160 times 60%, 96. So number of successes are 96 for the second, for the previous. 99. So B dash equals x199 plus 96 divided by n1 plus n2 350, and that will give the overall proportion divided by 310.629. So this is the value of the overall proportion. Now B dash equals 1629. So 1 times 1 minus B dash is 1 minus this value times 1 over n1, 1 over 150 plus 1 over 160. Simple calculation will give the value of z, which is in this case 1.093. So just plug this information into this equation, you will get z value, which is 1.093. He asked to do this problem by using two approaches, critical value and B value. Let's start with the first one, B value approach. Now your B value or critical value, start with the critical value first. Now since we are taking about a two-sided test, so there are two critical values which are plus or minus z alpha over 2. Alpha is given by 5%, so in this case it's equal plus or minus 1.96. Now, does this value, does the value of the z statistic, which is 1.093, fall in the critical region? Now, my critical regions are above 196 or below negative 1.96. Now, this value actually falls in the non-rejection region, so we don't reject the null hypothesis. So my decision, don't reject the null hypothesis. That means there is not sufficient evidence to support the alternative, which states that the proportion has changed from the previous study. So we don't reject the null hypothesis. It means there is not sufficient evidence to support the alternative hypothesis. That means you cannot say that the proportion has changed from the previous study. That by using critical value approach. Now what's about B value? In order to determine the B value, we have to find the probability that the Z statistic fall in the rejection regions. So that means B Z greater than, my value is 1093, or Z is smaller than negative 1.093. The area to the right of 1093 is the same as the area to the left of negative, so they are the same because of symmetry. So just take 1 and multiply by 2. Now simple calculation will give the value of 0.276 in chapter 6. So go back to chapter 6 to figure out how can we calculate the probability of Z greater than 1.093. Now my B value is 0.276. Always we reject the null hypothesis if my B value is smaller than alpha. Now this value is much bigger than alpha, so we don't reject the null hypothesis. So since my B value is much greater than alpha, that means we don't reject the null hypothesis, so we reach the same conclusion, that there is not sufficient evidence to support the alternative. Also, we can perform the test by using confidence interval approach, because here we are talking about two-tailed test. Your confidence interval is given by B1 minus B2 plus or minus Z alpha over 2 times B dash 1 minus B dash multiplied by 1 over N1 plus 1 over N2. By the way, this one called the margin of error. So Z times square root of this quantity is called the margin of error, and the square root itself is called the standard error of the point estimate of pi 1 minus pi 2, which is P1 minus P2. So square root of B dash 1 minus B dash multiplied by 1 over N1 plus 1 over N2 is called the standard error of the estimate of pi 1 minus pi 2. So this is standard estimate of P1 minus P2. Simply, you will get the confidence interval to be between pi 1 minus, the difference between the two proportions falls between negative 0.5 and 0.7. Now this interval actually contains the value of 0. That means we don't reject the null hypothesis. So since this interval starts from negative, lower bound is negative 0.5, upper bound is 0.17, that means 0 inside this interval. I mean the confidence captures the value of 0. That means we don't reject the null hypothesis. So by using 3 different approaches, we end with the same decision and conclusion. That is, we don't reject the null hypothesis. That's all for number 1. Question number 2. The excellent drug company claims its aspirin tablets will relieve headaches faster than any other aspirin on the market. So they believe that their drug is better than the other drug in the market. To determine whether excellence claim is valid, random samples of size 15 are chosen from aspirins made by Excellent and the Simple Drug Company. So sample size of 15 are chosen from each. So that means N1 equal 15 and N2 also equal 15. An aspirin is given to each of the 30 randomly selected persons suffering from headaches. So the total sample size is 30 because 15 from the first company and the second for the Simple company. So there are 30 selected persons who are suffering from headaches. So we have information about number of minutes required for each to recover from the headache is recorded. So the sample results are. So here we have 2 groups, 2 populations. Company, it's called Excellent Company, and the other one Simple Company. The information we have, the sample means are 8.4 for the Excellent and 8.9 for the Simple Company. With the standard deviations for the sample are 2.05 and 2.14 respectively for Excellent and Simple. And as we mentioned, the sample sizes are the same, are equal, 15 and 15. Now we are going to test at 5% level of significance. Test whether to determine whether Excellent's aspirin cure headaches significantly faster than Simple aspirin. Now, faster it means better. Better it means the time required to relieve headache is smaller than. So you have to be careful in this case. If we assume that mu1 is the mean time required for Excellent aspirin, so mu1 for Excellent excellent company, and mu2 for simple company. So mu1, mean time required for excellence aspirin, and mu2, mean time required for simple aspirin. So H1, mu1 is smaller than mu2. Since mu1 represents the time required to relieve headache by using excellent aspirin, and this one is faster. Faster, it means it takes less time in order to recover from headache. So mu1 should be smaller than mu2. We are going to use T. T is x1 bar minus x2 bar minus the difference between the two population proportions divided by S squared B times 1 over N1 plus 1 over N. S squared B, N1 minus 1 is 1 squared plus N2 minus 1 is 2 squared divided by N1 plus N2 minus 2. Now, a simple calculation will give the following results. So again, we have this data. Just plug this information here to get the value of S squared B, and finally you will end with this result. S squared B equals 2.095 squared. Your T statistic equals negative 0.653. So that's your T statistic value. So just plug the values of N1 and 2, S1 squared and S2 squared into this equation, you will get this value. So 2.059 squared, that is 4.239. Here you can use either the critical value approach or p value. Let's do a critical value. Since the alternative is the lower tail, one-sided lower tail, so your b value, your critical value is negative T alpha and degrees of freedom. So this is equal to negative T 5% with 28 degrees of freedom. By using the table you have 28 under 5%. So 28 under 5%. So 1.701. Negative 1.701. Now, we reject the null hypothesis if the value of the statistic falls in the rejection region. Now, again, since it's lower tail, so your rejection region is below negative 1.701. Now, does this value fall in the rejection region? It falls in the non-rejection region. So the answer is we don't reject the null hypothesis. That means we don't have sufficient evidence to support the excellent drug company claim, which states that their aspirin tablets relieve headaches faster than the simple one. So that's by using a critical value approach, because this value falls in the non-rejection region, so we don't reject the null hypothesis. Or you maybe use the b-value approach. Now, since the alternative is mu1 is smaller than mu2, so p-value is the probability of t smaller than negative 0.653. So we are looking for this probability b of z smaller than negative 0.653. The table you have gives the area in the upper tail. So this is the same as b of t greater than, because the area to the right of 0.653 is the same as the area to the left of negative 0.75 because of symmetry. Just look at the t table. Now, smaller than negative means this area, which is actually the same as the area to the right of the same value, but in the other side. So these two areas are the same. So it's the same as b of t greater than 0.653. If you look at the table for 28 degrees of freedom, that's your 28. I am looking for the value of 0.653. The first value here is 0.683. The other one is 0.8. It means my value is below this one. If you go back here, so it should be to the left of this value. Now here 25, then 20, 20, 15, and so on. So it should be greater than 25. So your b value actually is greater than 25%. As we mentioned before, t table does not give the exact b value. So approximately my b value is greater than 25%. This value actually is much bigger than 5%. So again, we don't reject the null hypothesis. So again, to compute the b value, it's the probability of t smaller than the value of the statistic, which is negative 0.653. The table you have gives the area to the right. So this probability is the same as b of t greater than 0.653. So by using this table, you will get the approximate value of b, which is greater than 25%. Always, as we mentioned, we reject the null hypothesis if my b value is smaller than alpha. In this case, this value is greater than alpha, so we don't reject the null. So we reach the same decision as by using the critical value approach. Any question? So that's for number 2. Question number 3. To test the effectiveness of a business school a preparation course, 8 students took a general business test before and after the course. Let X1 denote before and X2 after. And the difference is X2 minus X1. Now suppose the calculations give the mean of the difference equal 50, and the standard deviation of the difference is 65.03. So sample statistics are sample mean for the difference and sample standard deviation of the difference. So these two values are given. Test to determine the effectiveness of a business school preparation course. So what's your null? And alternative. Null equals 0 and alternative should be greater than 0, because D is x2 minus x1. So effective, it means after is better than before. So my score after taking the course is better than before taking the course. So x mu D is positive. T is D bar minus 0 divided by SD over square root of n. D bar is 50 divided by 65 divided by square root of 8. So 50 divided by square root of 8, 2.17. Now, you may use the critical value approach. So my critical value is T alpha, and the degrees of freedom is 7. It's upper 10. So plus, so T alpha 0.5, and DF is 7 because n equals 8. Now by using the table, at 7 degrees of freedom, so at 7, under 5, 1.895. So my T value is or greater than the critical region, so we reject the null hypothesis, because rejection region starts from 1.9895, and this value actually greater than 1.8. So since it falls in the rejection region, then we reject the null hypothesis. It means that taking the course improves your score. So we have sufficient evidence to support the alternative hypothesis. That's for number 3. The other part, a statistician selected a sample of 16 receivable accounts. He reported that the sample information indicated the mean of the population ranges from these two values. So we have lower and upper limits, which are given by 4,739. So 4.8 all the way up to 0.2. So the mean of the population ranges between these two values. And in addition to that, we have information about the sample standard deviation is 400. The statistician neglected to report what confidence level he had used. So we don't know C level. So C level is unknown, which actually is 1 minus alpha. Based on the above information, what's the confidence level? So we are looking for C level. Now, just keep in mind, the confidence interval is given, and we are looking for C level. So this area actually is alpha over 2, and the other one is alpha over 2. So the area between is 1 minus alpha. Now, since the sample size equal, what's this? 16? N equals 16. So N equals 16. So your confidence interval should be x bar plus or minus t s over root n. Now, C level can be determined by T. And we know that this quantity represents the margin of error. So E equals Ts over root n. Now, since the confidence level, the confidence interval is given, we know from previous chapters that the margin equals the difference between upper and lower divided by 2. So half distance of lower and upper gives the margin of error. So that will give 260 points. So that's E. So now E is known to be 260.2 equals T. S is given by 400 and N is 16. Now simple calculation will give the value of T, which is the critical value. So my T equals 2.60. Actually, this is T alpha over 2. Now the value of the critical value is known to be 2.602. What's the corresponding alpha over 2? Now look at the table at 15 degrees of freedom. Look at 15. At this value, 2.602. At this value. So 15 degrees of freedom, 2.602. So the corresponding alpha over 2, not alpha, it's 1%. So my alpha over 2 is 1%. So alpha is 2%. So the confidence level is 1 minus alpha. So 1 minus alpha is 90%. So C level is 98%. So that's the C level or the confidence level. So again, maybe this is a tricky question, but at least you know that if the confidence interval is given, you can determine the margin of error by the difference between lower and upper divided by 2. Then we know this term represents this margin. So by using this equation, we can compute the value of T, the critical value. So since the critical value is given or is computed, we can determine the corresponding alpha over 2. So alpha over 2 is 1%. So your alpha is 2%. So my C level is 98%. That's all. Any questions? خلصنا أبو محمد.